All right, hi everyone. We're looking at our next topic, which is the parallel lines and proportional parts of our similarity of ratios and proportions. So we're going to look at a couple of theorems today. The first is the triangle proportionality theorem. And we've seen some pictures similar to this already and looked at some ways that you can solve proportions with these kinds of triangles. But now that we specifically know these two pieces of your triangle are proportional, I'm sorry, not proportional, are parallel, that lets me get some other things to make out a proportion. So like the theorem says, if one line is proportional to a side of the triangle, meaning this line that's inside this triangle is parallel to a side of the triangle, then that line is cutting the sides of the triangle into proportional segments. So that means the side of that big triangle are cut into proportional pieces. So let's take a look and see what that means for us here. So if segment BE is parallel to segment CD, and they are, that's what those pink little triangles there mean, that's your parallel symbol, then these ratios and this proportion are equivalent, they are true. Make this fit it on the screen here. There we go. So AB, the length of AB, compared to BC, those two parts are equal to or proportional to AE and ED. So we can use those to make up our proportions. Oops, sorry, that's a little big. Let me shrink that down. There we go. So those two pieces are proportional. And again, notice they're from the same side of same small triangle, and same with the other two. They are proportional. And so we can use that to make your proportion to solve. All right, and we'll see some examples here in just a second with these. All right, now also with parallel parts of our triangles, you get what's called the triangle mid-segment theorem. So just like we talked about, midpoint is the point that cuts the shape or the segment in half. Mid-segment is a segment that connects midpoints. All right, so a mid-segment of a triangle is parallel to one side. So that's a clue here. Parallel to one side of that triangle. So it's going to go the same direction as one of the sides. And it is half the length of the side. All right, half the length of the side. So whatever side it is parallel to, the mid-segment is half that length. So let's see what we've got going on here. If J and K are midpoints, so just with that, based off our picture, if J is a midpoint, so that's where you get the 2 dashes on each side. K is a midpoint, so 1 dash on each side. Okay, of sides FH and FG. Then segment JK is parallel to segment FG. Meaning if I draw segment JK, I connect those middles, it is going to then be forced to be parallel to that third side of the triangle. And again, it's the side going the same direction as the mid segment. And that's where we get those pink arrows on there for. That is your symbol for parallel. So like it says, if JK is a mid-segment, then it is half the length of FG. All right, so just so that we can remember that. Your mid-segment is half the length. Clue there is half of the parallel side. Over. Okay, so if I know what JK is, I can figure out FG. If I know FG, I can figure out JK. I just need one of them. And again, we'll see some examples of that in just a second. Now, sometimes when you have proportional parts of in parallel lines, you may not necessarily get a triangle. So this time it says if 3 or more parallel lines, so 3 or more parallel lines intersect two transversals, then they cut those transversals proportionally, meaning they make proportional pieces all the way around. So let's see what we get. So right now it says if segment AE is parallel to, so segment AE is parallel to segment BF and is parallel to segment CG, then we can make this proportion. Let's see where that happens. So AB, which is that piece, over BC. Those two pieces, and I'm going to redraw that, make a little more space there. So this piece and this piece. Okay, so that's going to make up one of your ratios, is proportional to EF to FG. So the two parts that make up the left are proportional to the two parts that make up the right. So let's see, again, we'll look at some examples of these in just a second on how we can write these proportions. Now, the other thing that we get with our proportional parts of parallel lines is when those parallel lines are cutting congruent pieces. Okay, so same kind of situation. Those three parallel lines are making proportional parts, but because those parallel lines are equally spaced apart, that means these two pieces are equal automatically. And if the same is true on the left side or the right side, if one side is equal, so is the other. It forces the other side to be equal as well. All right, so those proportional parts are actually equal to each other. So AB is equal to BC, EF equal to FG. Again, we'll see some examples in just a second on how we can solve all these out. So let's see how we do. Let's start with our first example here. You've got two parallel lines towards the bottom of this triangle. And in triangle PQR, segment ST is parallel to segment RQ. So it tells me that if PT is 7.5 and TQ is 3. So right now, that makes up one of your ratios, according to the theorem. 7.5 over 3 is equal to, now let's keep going, SR, which is 2.5, find PS. So this is the piece I'm looking for. So again, if 7.5 is on top, X has to be on top. Use that parallel line that's there to help create your ratios. Use that as your division bar. So X over 2.5. Now we can do our cross multiplying. So 3 times X, 3X, 7.5 times 2.5. All right, and let's see what we get. That is 18.75 is equal to 3x. And now we can divide out the 3. And I get 6.25. And there's my missing piece. So PS has a length of 6.25. And there's my final, because it wanted the length of PS. All right, so again, that's using your proportional parts in the triangle. Now let's see what happens when we look at the mid segment. All right, so in this triangle RST, segment XY and XZ are mid segments. So if they're mid segments, if XY is a mid segment, that means X is in the middle and Y is in the middle. And then it says XZ is a mid segment. So that also means Z is in the middle. So I get all of these different equal parts if I know I'm looking at a mid segment. Find each of the measures we need. So first I need X to Z. All right, so if I redraw that without all that stuff going on, X to Z is this segment in your triangle. So for me to get this length, I need to look to the side that it's parallel to. And they told me that length has 13 units. So I should be able to cut that 13 in half. So 13 divided by 2. 6.5. Or 13 over 2 does not reduce. You could leave it as that. And for this one, I'm going to leave it as 13 over 2. All right, we're going to leave some things as fractions here for this one. All right, now we need S to T. All right, so S to T is this whole entire side of our triangle. So again, think if I redrew that. I need this whole entire side. So I want to see if I have the mid segment that would accompany it, because I need to look to that mid segment to see what could that entire length be. So let's see what it tells us. It tells us that has a length of 7. So if this length is 7, and again, 7 is half of that. So if I'm trying to get this piece, it's going to take 2 of those 7s to make that entire segment. So X is supposed to be 2 of those, so 2 times 7, which means it's 14. All right, now we need to get the perimeter of triangle RS and T. So let's see what we get. All right, brand new triangle here. All right, so we just found that our right side of the triangle was 14, so there's one of our values. We know the bottom of our triangle. That's the one that it says is 13. Now I need the other side, so that way I can add them all up. So again, if I can find the long side, or in this case, the mid segment, I might know how much it is. All right, so this one doesn't have the mid segment drawn. So I'm going to go back and erase that part. Not always do I have to use the mid segment. So I'm going to clear that out for just a second. But what I do know, remember, X is sitting in the middle. And on X to S, I have the length of 8. So let's use that instead. All right, if X is in the middle, these two pieces were the same. So if the top piece is 8, so is the bottom piece. And then all the way across, 16. Now I have enough to add these up to get my perimeter. So 16, 14, and 13, add them together. 43 is my perimeter. All right, so we've got all 3 of those just from knowing our little mid segments. All right, let's try some of our other proportional parts that we've got going on here. All right, so in example 3, X to M, it says is 4. Okay, make it a little bit bigger. X to N is 6. So I could use that to make one of my ratios if I wanted. N to Z is 9. Find X, Y. So I need to find this entire length. So I need to get this missing piece first so that I can add them up. So again, just as a reminder, let's go back and review where our parts are going to be. So again, this is our triangle proportionality theorem. So notice again, AB and BC in that green piece were from the same side. So we use the same side to make our first ratio. So I can have 4 over x and equals 6 over 9. And now we can solve this. 4 over x comes from the top side. 6 over 9 came from along the bottom. All right, so 6 times x, 6x. 4 times 9 gives us 36. Divide out your 6. And my x is 6. So this whole entire side, 6 plus 4, which means my x to y has a length of 10. All right. Let's go over to the next one. Example 4, find x and y. So we have 3 parallel lines here cutting those 2 different transversals equally. Those parallels are equally spaced apart. How do I know? Because the dashes are here to tell me that. So if I've got dashes on one of these lines, that means these 2 parts are equal. So let's solve that real quick. 3y plus 8 equals 5y minus 7. All right, I'm going to subtract 3y to both sides. So 8 is equal to 2y plus 7 minus the 7 to both sides. Oh, I'm sorry, not minus 7 plus 7. Sorry, it's 2y minus 7, so add it back. So 15 is 2y, divide by 2. And there's my y. And again, I'm just going to leave it as 15 over 2. Now, this theorem says if one line is being cut into equal parts, that automatically means the other is 2. So if one side is equal, so is the other. Now let's find x. 6x minus 5 equals 4x plus 3. So minus the 4x to both sides. 2x minus 5 is equal to 3. Add your 5 back. So 2x is equal to 8. Divide your 2. And your x is 4. So there we found our 2 pieces. It wanted x and y. But again, you can only set those equations equal to each other as long as one of those transversal lines has a set of dashes on it. Because if one of them has the dashes, the other one can be set equal as well. All right, let's look at example 5 and kind of wrap all of this up. This is our last piece here, and it's looking at all the different ways you could possibly write out the ratios for your parallel parts on parallel lines in your triangles to make proportional parts here. So we're going to go through these different ratios that are here for your answer choices and see which one is not true. All right, I've been just like we talk about in class or in the Zooms, however you choose to write your first ratio, the second one must follow the exact same pattern. So let's see what's going on here. We have AB, so that is this side, over BE. So these 2 pieces are coming from the small triangle. All right, there's the small triangle. You're looking at the left side of the small triangle and the bottom of the small triangle. So we're comparing left to bottom. Let's see if we compare left to bottom of the big one. So now we need AC. Okay, that works. And CD. So that takes care of our big triangle. Left of the big one, bottom of the big one. That one is a true proportion. Let's check B and see what happens there. All right, A to E. And I'm going to make this just, there we go, A to E and ED. Okay, so that's on one side. So this is left side, left part, left part. Now we have AB and BC. That is a true proportion. That's one of the first ones we looked at in the notes. That was this guy, the triangle proportionality theorem. So this one is also a true proportion. So that one works. Let's try C and see what happens. AE and BE. All right, so AE and BE. So this is right side to bottom. ED and CD. All right, ED and CD. Okay, so this one does not actually work because again, you're comparing the right side of the small triangle to the bottom of the small triangle, but you don't compare the whole entire thing from A to D with DC. That's what it would have to be. So this one is not correct. That one is not true. Let's check out D and see if there's possibly another one that's not true. So we need AB and AE. So let's erase this. AB and AE from the small triangle, the whole left side and the whole right side. And we're comparing it to BC and ED. That one is also true, because remember, it cuts it into proportional parts. So this one also works. That one is true. So C is the only one that does not match. All right, guys, I hope you enjoyed learning a little bit about your proportional parts when you start bringing in your parallel lines. Please don't hesitate to reach out to me if you have any questions at all. Bye, guys.